Wow, that's an idea. All right, the fundamental theorem of algebra. If f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. Let's pause here a moment, because maybe we don't know what that means. Everything now is considered to be a complex number. And either it's imaginary or it's real. Before you studied in Algebra 2 imaginary numbers, we only knew about real numbers. And under the set of real numbers, we have two divisions. You have irrational numbers. Anybody remember what's an irrational number? Can't be written as a fraction, like pi, radical 3, e, things like that. And then you have your rational numbers, which can be written as a fraction. Then we had our integers, we had our whole numbers, and you have your natural numbers. So just think, I mean, back to kindergarten, you start with natural numbers. First grade, you do whole numbers. You really don't hit integers until about 5th grade. 5th grade's where we start working with negative numbers. Oops. Yeah, and then you do work with positive rational numbers, though, in 2nd grade, 3rd grade, and so on. Okay, but here's kind of a big picture of what's going on. So it's saying if f of x is a polynomial of degree n, there's at least one 0 in the complex number system. So I want you to understand that's everything. Okay, there's at least one 0. So if you look at example 1, it says find all the zeros of the function f of x equals 3x times the quantity x minus 2 squared. So what's another word for a 0? Adam, do you remember what's another word for 0?
A solution.
Good job. Okay, that's a solution. Ben, do you remember even another word for 0 besides solution?
X-intercept.
Awesome. Okay, that's an x-intercept. The other thing is, you could call it a root as well. Okay, so good job remembering that. So if they ask you to find a 0, they're asking you to find the solution or the x-intercept. Sometimes it's referred to as a root. So x is 0 is a 0, and x equals 2 is a 0. Now, based on what we learned previously, x equals 2 has multiplicity 2, doesn't it? Because it's to the 2nd power. So that's pretty cool. All right, now the rational 0 test. The reason why I asked you to open your books to page 244 is I want you to look at that blue box. I felt like I didn't write it clear enough in your notes for you. So it says, suppose you have a polynomial function f of x. Now, a sub n x to the n power. A sub n is the coefficient of the leading term, okay? And then look all the way at the end. A sub 0 is your constant. So this rational 0 test, what it's saying is if you think about what, and I'm so glad we wrote this down, a rational number is a number that can be written as a fraction, okay? So the rational 0 test is telling us what are the possible rational zeros. And then it's not telling you about, like if I can get square root 3, it's not telling me anything about irrational ones. But it will tell me which are the possibilities, and you can test to find all the rational zeros. So it's actually pretty cool. And if you're going to go on to AP Calculus, they're going to force us next year on the non-calculator part of the exam to use this rational 0 test. Because sometimes it'll come up and they're like, we don't know how to do this. I'm like, rational 0 test. Because if you look at example 2, if we look ahead, this isn't going to factor. And if you can't use your calculator, the only method we have is this rational 0 test. And here's what it says. If you let p be the factors of the constant, and q are the factors of the leading coefficient, then you just take p divided by q. So here's what we're going to do, and we're going to do lots of these. I have an extra worksheet we're going to do. So p is going to be the factors of the constant, okay? So let's write ourselves a note. P are the factors of the constant. Well, in order to get a 1, you could do 1 times 1 or negative 1 times negative 1. So we'll write plus or minus 1. Q represents the coefficients of the leading term. Well, that's also plus or minus 1. The rational zero test says that the possible rational zeros are all the combinations of factors of the constant term divided by the factors of the leading coefficient. And what helps me remember this is in the Bible, do you remember where it says the last shall be first and the first shall be last? So the last is going to be first. It's going to go in the top of your fraction, okay? So if I do all the combinations of plus or minus 1 divided by plus or minus 1, isn't that just going to be plus or minus 1? Yeah, we did do this last year, remember? In Algebra 2? So then, all I have to do is I'm going to check f of 1. So that's 1 cubed plus 1 plus 1. Okay, that's not a 0. And then we're going to do f of negative 1. So it's negative 1 cubed plus negative 1 plus 1. So negative 1 and 1 are not zeros of f of x. And what that means is there are no other rational zeros. There's no other possibilities. Now, there could be decimals like 0.12578, goes on forever. There can be other real solutions. Or what we're going to learn later today is that they can come in complex conjugate pairs, okay, to be imaginary. All right, let's look at example 3 then. We want to use the rational zero test to find the rational zeros of g of x equals x cubed minus 7x minus 6. So the factors of p would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The factors of q would be just plus or minus 1. So we're going to take p divided by q. So this is not very interesting because you're just taking them all divided by 1. Now what I would recommend is let's pop g of x into our y screen. Okay, let's go to the y screen. Excuse me. Thank you. And that's x cubed minus 7x minus 6. Yes.
Are we done with our books?
Yes, you can close your books. Now, I'm going to make sure my calculator, because I was doing something else earlier, I'm going to put it back on auto.
Check your mode, check your mode, check your mode.
Check your mode, check your mode. Alright, so we're going to put it back, make sure you're on the auto, and then do you notice that we're only scrolling from really negative 6 through positive 6? In the table, do you see that when x is negative 2, it's a 0. When x is negative 1, it's a 0. And let's see if there's any more. And x is 3 is a 0. So this is meaning that g of negative 1 is 0, g of negative 2 is 0, and g of 3 is 0. How do I know that I don't need to go look anywhere else? How do I know that these 3, Stephanie?
Because you're only going to have 3 because of your
Degree.
degree.
Yeah, if you look, this is degree 3, so there's only 3 possible zeros. It doesn't mean they're always all 3 rational, but you're right. So x equals negative 1, x equals negative 2, x equals 3 are zeros. They're actually rational zeros of g of x. Okay, so what I want to do, just to make sure we practice and get the hang of this, is we're going to step off these notes. do number 1 and number 2 with you and then give you a few minutes to work on your own. So in number 1, it says f of x equals x to the 4th minus 5x cubed plus 9x squared minus 7x plus 2. And we want to find the rational roots, and roots are zeros, mean the same thing. So p, the factors of 2 are plus or minus 1, plus or minus 2, and q is just plus or minus 1. So we're going to do p divided by q, and that's just plus or minus 1, plus or minus 2. So what you're going to want to do, we only have 4 to try. Whether you opt to do them by hand or plug them in your calculator is up to you. Yeah.
If you did them by hand, could you use that remainder theorem thing?
Synthetic division?
Yeah.
Yes, I like that. Okay, Tyler asked a really good question. Do you understand, based on what we did in the previous lesson, you could do synthetic division, and if your remainder is 0, it is a 0. Okay? That's an alternate way to do it instead of plugging in. Because remember, we have that remainder theorem. So when I did these, I got x equals 1 and x equals 2 are the rational zeros of f of x. Are you guys getting it? 1 and 2. Alright, now let's look at number 2. I'm going to call that f of x equals 2x cubed plus 3x minus 5. So we finally got one a little bit interesting. The factors of p are plus or minus 1, plus or minus 5. Q is plus or minus 1, plus or minus 2. When you're working these out and you're asked to determine the rational zeros by the rational zero test, the minimum you need to give me, because I know some of you can do it in your head, if you can do it without listing p and q, I need p divided by q. That's the minimum. And I'll tell you on the next quiz, because we'll have a quiz on 2.5 and 2.6, one of the quiz questions asks you to list the possible rational zeros. I don't ask you to find them, I just say list them. And that's telling me, do you understand how to do that? So you're going to take 1 divided by 1, 5 divided by 1, and then we're going to take 1 divided by 2 and 5 divided by 2. So just in case you forgot how to do this on your calculator, let me show you how to do this. Go back to your Y screen, and let's put in 2x cubed plus 3x minus 5. And then what you want to do, because we have some fractions to put in, you can do second window. Again, that's second window, and that's your table setup. And go down to independent and turn it to ask. Now we'll go second graph, and it should be blank or there's numbers in there that you left in, and you just start entering them. So right off the bat, I got x was 1. I can do negative 1/2. I can do positive 1/2. 5, negative 5, 5 halves, negative 5 halves. Okay, do you see how you can use the ask feature? You can turn that on and you can turn it off. So I only have one rational zero here. So x equals 1 is a rational zero of either y or f of x, okay? All right, go ahead and try 3 through 6 now. I'll give you a head start. 4, and 6 are not bad, but 5 has a huge amount of options.